Our thesis as a company more and more is that AI is still just engineering. Those people who tell us for fun and profit that somehow AI is so profound, so new, so different from anything that's gone before, that it somehow eclipses the need for good engineering practice are wrong, and that we need that good engineering practice still. And for the most part, most things are not new. Most things we have to go and do are not wholly new, but there are some things that have become slightly more important with AI. One of those is durability.
That was Samuel Colvin, creator of Pydantic and leading the team that's building the Pydantic stack, validation, AI, and Logfire for observability, on why building with generative AI remains, fundamentally, a software engineering challenge. Samuel's a dead set legend, and I was so glad that he joined me to discuss the transition from experimental prototypes to durable agents, robust systems built to survive network failures, and the inherent stochasticity of LLMs and generative AI.
If you're calling an LLM and that's taking somewhere between 3 and 300 seconds, and then you're going to go and call 10 of them in a row, you really don't want to have to start again, and you really don't want to have that to die every time your Kubernetes node gets killed. And so durability is about effective. I mean, there's lots of ways of talking about it, but fundamentally it's about recovering from failure and resuming from where you left off.
With respect to agents, Samuel describes a bathtub curve of constraints. Coding agents can be messy because a human is watching, but production agents need engineering-grade reliability. He makes the case for splitting agents into deterministic workflows and stochastic activities so you can cache results and skip redundant LLM calls during retries. We also get into context engineering, why agentlets are replacing the mega agent paradigm, and a prediction that AI observability won't exist as a category in 5 years. It'll just all be observability. Samuel also walks through live demos of durable agents and deep research. He talks us through the code as he goes, so you can follow along even if you're just listening. If you want though, you can also check out the video on YouTube. This conversation was a Q&A from a recent cohort of our course, Building AI-Powered Applications, which I have the great pleasure to co-teach several times a year with my friend, Stefan Krautchik, who works on AI agent infrastructure at Salesforce. Links in the show notes if you're interested. We also live stream many of our podcasts and free workshops and would love you to join. Check out the Vanishing Gradients Luma calendar and subscribe to our Substack newsletter and YouTube channel. All links are in the show notes. If you enjoy the show, the best way to support it is to share this episode with a friend or colleague who you think would get something out of it also. I'm Hugo Bown-Anderson, and welcome to Vanishing Gradients. And we are live. What's up, Samuel Colvin?
Nice to see you, Hugo. Yeah, all good, all good. Yeah, very happy to be here.
Always a pleasure. I always enjoy our chats and I learn so much from you. We've been doing so much in this course. There's a lot of new stuff we've been covering in the course, because last time we taught it was July, of course, when you came and talked about and showed us all about self-healing agents. But there's so much more now in the space around multi-agent systems, how to handle context, and this new idea of context engineering, which seems like a good term for a lot of what we're all doing here. And I'm really excited to talk about durable agents and how they relate to all of these different things. But I thought people, of course, everyone knows who you are because of Pydantic. One thing I'm interested in, could you just give us a bit of your background? Because you didn't build Pydantic for AI reasons at all, right?
Yeah, absolutely. Yes, Pydantic predates Gen AI by a few years. So it started in 2017. I was running a software company back then. In fact, I was trying to build something to parse HTTP headers, and I found myself duplicating the type annotations of whatever it was I was trying to extract, and the validation. I forget what I was using at the time, probably doing it manually, and it just seemed mad. And so yeah, Pydantic started off as this project, a side quest in a directory in an existing project to see if I could use type annotations to validate data, and turned out it took over my life, and here I am 8 years later doing nothing but Pydantic, although Pydantic is now some more things.
Well, also, as it turned out, Pydantic is all you need, as we know. I also am interested in, so firstly, thank you so much once again for sponsoring the course and all the credits you've given everyone to experiment with Logfire.
No problem at all.
And I am interested in what you're working on and what you've built and why you're doing this now.
Yeah, I think obviously Pydantic became a company. I mean, you can talk about why we do it commercially, but I think why we do it from the passion of why it's interesting. I think Of course, there's the like building of LLMs, which is a fascinating subject in itself. But like what I have always been good at and what I've always been interested in is taking the like low level or the science and turning it into engineering, taking the very complex theoretically what's possible and making it easy to do from an actual engineering point of view. And so, yeah, I mean, I think that right now the apex of what's interesting in terms of software design is how you do that with LLMs, whether that is building software with LLMs or building software that uses LLMs, observability, and how that relates to AI. I think that's a really fascinating space. That's why I enjoy what I do. We get to go and like invent ways of doing things.
Cool. And so I suppose I'd love to know what you've built, Pydantic, we know Logfire, what else is in the mix, and why did you prioritize these things?
Yeah, so we do 4 things today. So we do Pydantic validation, the OG library. It's relatively stable for the most part, although actually we have some really exciting improvements coming up over the next few months. We have what we call struct, which is this idea that like we can late materialize the data, and therefore we can improve performance of validation by up to kind of 3-4x, but also make it more flexible, also reduce memory, but like we should support validating of like arrow data directly and this late materialization stuff that improves performance. So, but yeah, first thing is Pydantic validation. Second thing is PydanticAI, the agent framework, but also we have Pydantic Evals in there. There's PydanticGraph. There's the durable execution stuff that I'll talk about today, where instead of reinventing the wheel and trying to invent our own thing, which others in our space have tried to do and I think failed, instead we're integrating with the people who are best at doing durable execution to give you battle-tested ways of supporting that. Then we have Pydantic Logfire. I still believe that AI observability will not be a term in 5 years' time. I think AI will be a required feature of observability, just as there's no such thing as web observability or cloud observability. But today, working out what it is to observe AI applications and the AI observability, both on the eval side and on the prompt management and all the other stuff, is like more and more of our focus within Logfire. And of course, the problem with a growing company is you are always at the limit of the performance of your database. And so we always are grinding to try and make the database cheaper, faster, better ingest, all that stuff. And then the last bit is PydanticAI Gateway, which we announced now 2 weeks ago or a week and a half ago. That's the latest bit in the stack.
Well, many congrats on everything, in particular the recent announcement of Gateway. I do want to jump in to talk about durable agents. I can say durable here. It's a safe space for such intonations. You and I have had a bunch of conversations around, for lack of a term, kind of being a bit fed up with the lack of robust software engineering principles in a lot of the space. And when I played devil's advocate with myself, I asked myself, the surface area of what's possible with software and what software means, I think, has expanded so much. I suppose I do ask myself, do we still want software to be reliable and consistent in all the ways we expected? Or is there room for other types of things?
So I think that there is a continuum of how constrained the problem is and how willing you are to accept unusual behavior, including outright failure, as in like network failure, the thing crashed. And that is basically a bathtub curve today. We have the two extremes of on most continuums. You have a like bump in the middle, which is where everyone sits, and there are like weirdos at both ends of the spectrum. This particular continuum is the opposite. We have the two extremes populated and very little in the middle. So we have at the one end, the least constrained, most willing to accept odd behavior or failure are the coding agents. They're running locally on a machine. They have hopefully an adult, sober adult, not always entirely sober, not always entirely acting like an adult, but like there's a human watching what they're doing for the most part, and you don't really mind how wrong they go. For the most part, we use like don't do stuff outside the current directory as our level of sandboxing. We may do some better sandboxing than that, but they're pretty unconstrained, and that's kind of the idea. They can go and use all of the tools in the toolbox to try and solve problems. At the other end of the spectrum, we have agents that we go and put into production, where we generally have a much more constrained space for what we allow them to do. We're much more concerned about security. We care a lot more that they are reliable and repeatable and that they will do the same sort of task 300 times in a row without going wrong. We care much more about latency and cost and all that stuff. So I think in the first category, where basically LLMs are replacing our fingers, we're prepared to accept them going wrong. quite often. And actually, Codex and Claude Code don't do a half bad job of actually tolerating using them on a plane. I was in New York last week and I was coding with both of them on the flight both ways. And sometimes they would like grind to a halt, but for the most part, they would work. But in the other case, I think we're not happy with the idea that one network failure will cause our agentic flow that was going to take half an hour to go wrong and have to be restarted. Does that answer your question a bit?
It really does. And it speaks to, I think, how much risk one wants to take on with what the software one's working with and also building from our side. I think related is just timescale of feedback loops as well, right? Because cursor's pretty quick most of the time. And so and it does wrong stuff all the time, but the timescale of my ability to have a feedback loop with it is pretty good. Similarly, I've been using Manus a bunch recently to help with research, and it will go and compile a bunch of research on a podcast or something I want to do in 10 minutes. That's pretty good, but I need to iterate with it a few times. If it took 10 hours, that wouldn't work for me, right? But the fact that it takes 10 minutes and then I can iterate is pretty powerful.
Yeah. Yeah, but also I think that you're using an LLM, ignoring your like ability level. You are comfortable with the fact that you are doing something that's fundamentally stochastic. If you are looking for a recommendation on a shopping site, you probably are not comfortable with it just like randomly recommending completely the wrong thing. You don't find it funny if it recommended something obscene to you when you're looking for a children's toy. If it recommends a sex toy, you are not happy with that like hilarious mistake. Whereas you might be amused by the like Adam from Prefect was giving a great talk the other day where he had asked a deep research agent to go and research set. Now this is going to challenge me. 1686, which is the set for long-running tasks at MCP, and it had come back with the Battle of September 1686, which was where the Ottomans defeated someone or other, I forget who. It was hilarious that set 1686 was the wrong thing, but because he was using an AI, we can all sort of guffaw at the fact that the LLM got it wrong, but there were situations where that's really not okay. The shopping example I give, but you can think about lots of other ones in medical, even if it's more mundane and it's like processing the values in an invoice, if no human's ever going to go and look at that, and turns out 10% of the time we are allocating things wrongly, that's not good enough. In fact, I might be able to show an example of a like fairly subtle failure in a minute, but I can't pretend I came up with it on purpose. It came to me, but anyway.
Awesome. Let's jump in. We're here to talk about durable agents. I do want to know what durable means in a second. I'm wondering if you can just tell me what agent means first.
So there are three definitions of agent. This is one of my go-to jokes at the moment. There are three definitions of agent. There's the LLM or AI people's definition of agent, which is an LLM calling tools in a loop. There is the infra person's definition of agent, which is a microservice. And then there is the business person's definition of agent, which is something that can replace a human and take their salary away. At the beginning of the big thing that's changed this year is at the beginning of this year, we thought that ignore the business person, they're wrong completely. But like we thought that one infra agent, one microservice would contain one AI agent, one calling tools in the loop. More and more, I think this is still the year of the agent, but those agents have stopped being like one agent that does our entire service, microservice thing. That like agent is now made up of many agentlets inside it that will go and do subtasks. An agent has sort of become, at the risk of sounding really pretentious and VC-ish, agent has become the kind of quantum of AI, the like building blocks where we plug together multiple different agents to do tasks, rather than having one agent that has all of the tools and all of the control and all of the time and will always get it right, which we've sort of learned isn't generally the case.
I love it. So what does durability mean then? And when is it important as well?
I think that our thesis as a company more and more is that AI is still just engineering. Those people who tell us for fun and profit that somehow AI is so profound, so new, so different from anything that's gone before that it somehow eclipses the need for good engineering practice are wrong, and that we need that good engineering practice still. For the most part, most things are not new. Most things we have to go and do are not wholly new, but there are some things that have become slightly more important with AI. One of those is durability, because if you're making, let's say you have 6 database requests to make to do some transaction for a user, like update their balance or whatever it might be, that you could do that in, let's say that fundamentally we're looking at sub 100 milliseconds for each of those queries. You can do them in 600 milliseconds and you can return to the user. And as long as they are all atomic, you don't really mind trying them again a few minutes later if they went wrong. If you're calling an LLM and that's taking somewhere between 3 and 300 seconds, and then you're going to go and call 10 of them in a row, you really don't want to have to start again, and you really don't want to have that to die every time your Kubernetes node gets killed. And so durability is about effective. I mean, there's lots of ways of talking about it, but fundamentally, it's about recovering from failure and resuming from where you left off. It's about recovering, and that failure can either be a node shutting down or a network request going wrong. And then some of the durable execution frameworks like Temporal also allow us to write some code, which you write a sort of normal deterministic code, or not deterministic, but like procedural code. Let's say I want to send an email 24 hours after someone has signed up. I don't need to go and set up tasks for that. I can just sleep for 24 hours and then send an email, and the Temporal will take care of basically turning off that process and resuming it when it needs to run. That's not really, I don't know whether they would call that a like core component of durable execution. I think it's a like very nice cherry on top, not the kind of the core nature of it.
Great. And I didn't actually plan this, but this chat couldn't have come at a better time, because the workshop we just did, we covered a lot on agent reasoning loops and then agentic research as well, which I know is something that interests you and motivated this for you quite a bit.
Yes, so I have what I call the like treasure hunt. I think of the like treasure hunt case of agents. So where basically you can't get to the answer immediately. You need to go out and find some intermediate step along the way. And then with that, you can go and find the next step and the next step. You think of it like those old school computer games where you had to go off and like ask the woman at the end of the lane where the secret potion was, and then you went and asked someone, you found the secret potion, you drank it, then whatever it is, right?
Yep.
There are lots of cases in real world that feel somewhat like that. And deep research is kind of the like quintessential example. You can't start reasoning about your response until you've gone off and done your research, but you probably need a few steps of research until you found all of the information, because you don't know what you're looking for until the end of the first one, etc. And so the example I'll show you now, I'll share my screen if that's all right.
Yeah, great. Absolutely.
And I'll do some aggressive zooming in so people can see it.
Love it.
I'll share my entire screen and then do some aggressive zooming in so you can see this example. Hopefully people can see that. Let me know via Hugo if anything that I'm showing is not clear.
So we can see all your code, but yeah, zooming in would be amazing.
So I think I've zoomed in quite a lot there. Hopefully that's big enough that it should appear on screen.
Yeah, looks good to me. But you could actually fill your whole screen with it potentially as well.
Yeah, it won't be wide enough. I think we're getting towards.
Yeah, that's the limit.
That should be pretty big. So here we're playing, as the file name suggests, 20 questions. So we have, the game where you basically, normally you would answer yes or no to something, and someone would try to guess what you're thinking of. In this case, it turns out LLMs are quite bad at playing 20 questions, and so to give them a better chance of answering, we actually have a categorical set of 5 different categorical answers: yes, kind of, not really, no, and completely wrong. And then we have our answerer agent, which has got a very simple task. It's just going to take in the secret object that it's thinking of. It's got one prompt, which is you're playing question answer game. Your job is to answer questions about a secret object only you know truthfully. And you see, because this is a relatively simple task, I'm using, in this case, Haiku 35, sorry. So this is our answerer agent, not in some sense the core bit of what we're doing here. And then we have our game state and our questioner agent, which has a bit more of a prompt, which is going to go and ask those questions and try and find the answer. And ultimately what it's doing is it has one tool registered, which is ask question. And inside that tool, we're going to use the answerer agent to answer the question that we've been given and return that output. And so it's going to run in a loop. The questioner agent is going to call this tool to ask the answerer agent, and it's going to try and work out when it's got to the right answer. And once it gets to the right answer, it will then exit.
And can I just ask, do we need agents for these, or would an LLM with just basic memory be fine there, or for these sub-agents, I suppose?
So the questioner agent is going to run an agentic loop. It's kind of the definition of an agent, right? It's going to call a tool in a loop until it arrives at an answer. So if that's not an agent, then what is?
Okay, great.
The answerer agent, so this doesn't have a tool registered. We use this add answer context manager to insert the answer from depths so that we don't have to encode the actual answer within our definition of the agent. This, in theory, doesn't need to be an agent. Now, it turns out even here we get an agentic loop because it's going to have to return some structured data, in this case, an instance of answer. And so if we were using a dumb enough model that it sometimes got this wrong, we want that agentic loop to basically reply to it and say, you got that wrong, please try again. But yeah, you could argue that one doesn't need it. And so, but I'm going to come over here and run it, and I'm going to make my window much bigger so you can see it. I'm afraid I'm just not cool enough to use my terminal, the terminal within the IDE. So you get a separate terminal, but you should be able to see that. And I'm going to run, to be clear, this has no durable execution within it, but I kind of need to show you the simple case to show you what's going to go wrong. So I'm going to go and run that. The other thing to see here is I've instrumented it with Logfire, so we'll be able to see the agent's running. I'll show you that in a moment as well. But if I go and run this, what have I done wrong? UV run. You should see it thinking about the question, and then you'll see it asking questions. I'm just printing out the answer here, not using Logfire's terminal output. So you can say it's saying, is it a living thing? Kind of. Oh, so the answer is potato in this case.
Okay.
And it's trying to work towards the answer. And you can come over here to Logfire, and you could see our 20 questions being played back and forth, and we can see the individual spans as they're going on.
Can you just zoom in there a bit as well?
I can try. I mean, it's not that easy to
no, that looks good. That's great.
That much, but you get the idea of, we get the token counts, we get what we spent so far, just gone over 1 cent, and we can go and look into an individual exchange with the answer agent here and what the exchange was. You can see it's using a tool call to do the structured categorical response. And in this case, success. It got to the answer potato in 14 steps. But if we ran this again and we let it get some way in, and now either we get a networking error that would cause it to raise an exception and crash, or the node that's running this agent had to shut down and it gets killed. Now, of course, we've lost our progress. We're going to have to start again. And if we start again, we start from 1. And so this is an obvious candidate for something where we would love to be able to resume from where we were at without having to build our resume stuff into our agent graph, which would be, unless you thought very hard about building that, it would end up not being type safe, and it would not be resilient to all the different kinds of failure, and it wouldn't be able to resume from the most recent spot. So that's where durable execution comes in. So I'm going to look at another example of this 20 questions game, but here we're going to use Temporal as our durable execution framework to run it. It's worth saying there's another example in this repo, which is open source, that uses DBoss, which is another durable execution framework. I think today I'm just going to talk through Temporal because they're kind of the big 300-pound gorilla in the durable execution space.
And OpenAI even uses Temporal, right?
That's right. So if this is obviously very similar to a deep research case, I've got a deep research version of this code here as well.
Cool.
Yeah, they use them, and I think Anthropic. I'm not sure, but I think Anthropic as well also use this. So
would it be possible to pivot to the deep research case just because we've been covering deep research today, or will the setup be too?
I can try. I'm going to whiz through this one really quickly. How long?
Okay, great. As long as you want.
Okay, I'll go through this one quickly, and then hopefully we can get to it.
Yeah.
So you'll see here that we have our answer agent. I've actually simplified it here, so it's just returning a bool, true or false. And then we have the difference here is we take our temporal agent type from PydanticAI and we wrap our agent in temporal agent. This gives us back something which is an abstract agent. It will behave exactly like an agent, but we have done the hard work of inserting temporal into it. So temporal works by splitting up code execution into workflows and activities. And the workflow is the main programmatic deterministic execution of your task. So it cannot do file system access. It can't do IO. It can't do anything which might be random. It has to, given the same inputs, has to behave the same way each time. And then all of the stuff that will do IO or access to file system or anything like that is an activity. And effectively what Temporal is doing behind the scenes, I have somewhere a graphic which makes this even more complicated to understand. But fundamentally what Temporal is doing is it's caching the answer to each activity as it runs. And so if you want to retry this particular workflow, Temporal can basically plug in the numbered responses to each of the activities. So that's why it needs to be completely deterministic, the workflow, so it can always know for certain which answer to which activity it needs to plug in. But if you were writing normal code, you would need to go and annotate things with workflows and activities all over the place. The nice thing about using PydanticAI is we have gone and done all the hard work to wrap stuff in Temporal. So you will write almost exactly the same code. You will have a bit of ceremony, as I'll show you at the end of this repo, end of this file, to run it as a workflow, and hey presto, we get the durable execution. So for the most part, that involves wrapping our agents in this temporal agent. So we have the same question agent here. Again, it has capacity to ask a question. Again, it's wrapped in durable in temporal agent. You will see here inside this tool call, basically 10% of the time, it will raise an exception. And I've added that to demonstrate what it would be like if we had some networking issue where unreliability of our upstream model, so we were getting periodic failures. It's worth saying that both LLM calls and tool calls with PydanticAI are wrapped in activities. We're the only agent framework that does that properly. So in my opinion, the rest of the agent frameworks which claim to have some degree of durable execution are kind of chocolate teapots, because all of your tools are going to end up needing to be activities. And if you don't automatically make them activities, they're kind of unusable. But anyway, so we have relatively similar agent. We just wrapped it in our temporal agent. Then this is where we get to the kind of temporal code. So we define our workflow like this. So we have a class that is decorated with workflow definition. Then we have a workflow run here. This is all kind of temporal's ceremony. I don't think it's particularly pretty, but it does what it needs to do. But in here, ultimately, all we're doing is calling our temporal question agent, which is how we kick off our game of 20 questions. We just give it the input start as we did before. And now we've defined our workflow, we can then go and play the game. And here we're going to do a bit more setup. So we will create a temporal connection that's going to connect to the temporal server, which is taking care of this. We register some plugins for Logfire and PydanticAI, which do some work behind the scenes. And then we define our worker, which again, we have a name, we have the workflow. And again, we define some plugins that are necessary to basically do all of the plumbing. And then we get to where we basically kick everything off. And ignoring this case for a minute, here, we're just going to call execute workflow to start running our workflow. And we give it an ID that we can get back. And that's all we really need to do to kick off our workflow. I'll get to what's going on here.
Now for a word from our sponsor, which is, well, me. I teach a course called Building AI-Powered Software for data scientists and software engineers with my friend and colleague Stefan Krautchik, who works on Agentforce and AI agent infrastructure at Salesforce. It's designed for people who want to go beyond prototypes and actually ship AI-powered systems. The link's in the show notes. Super cool. And we have a question or a set of questions from Brad, and he thinks it's been answered. He's still trying to wrap his head around a few things. So Brad has asked, is Temporal basically the framework behind managing failures and so on? And then he says he hasn't quite connected the dots. What would be the difference between using Pydantic and Temporal versus a LangChain flow? And he thinks he's still trying to wrap his head around it. So I'm wondering if you could just help.
So I think LangGraph has their graph structure has support for snapshotting, which is their, like, in my opinion, somewhat rudimentary attempt to do the same kind of thing. The point there is that you only get the snapshotting at the end of each node. And to have snapshotting and parallel node execution, you basically have to give up on all type safety. Whereas here we don't have any, you'll see here that there are no squiggly lines anywhere in this file. This is completely type safe. We take type safety very, very seriously inside PydanticAI, because I think it's absolutely key to building modern software. You cannot implement graphs with parallel node execution and snapshotting and keep it type safe. It is like, I can explain why in detail, but fundamentally it's impossible. So their equivalent would be LangGraph. I think that, like, no one's credibly arguing that that's a serious option. My apologies for being rude, but like, I think LangChain, you know, when you go to the beach and you can pick up that bat and ball and like hit the bat and ball back and forth, LangChain and LangGraph are the like plastic bat to Temporal and PydanticAI, which is the like tennis racket you might go to Wimbledon with. They're not for professionals; they're for amateurs as they get started. And anything else is basically, to argue anything else is dishonest, I would argue. Although I'm obviously opinionated in that take.
And how are people doing this more generally, or are people hand rolling like with retries and catches and?
I mean, I think serious people are using Temporal and DBoss and other durable execution frameworks. I know that we have a lot of people who've picked this up and used it within PydanticAI. I know there's a bunch of people who will use the underlying SDKs directly, not use PydanticAI, but use Temporal. Like, look, there will be people who are managing other routes. I doubt very many serious applications are using LangGraph or LangChain. I suspect that I think the two credible ways of doing it are using the SDKs directly or using PydanticAI. And the hybrid one is OpenAI agents, their SDK, which is also a quite serious answer. And that's no coincidence because they basically copy pasted PydanticAI. And so it has many of the advantages and they've introduced some disadvantages along the way, but it's useful. Anyway, I'll stop trash talking all of the competitors and run this example quickly. And then I'm happy to come back. So in this window here, I'm going to run the temporal server. So I'll make that a bit bigger so you can see it.
Awesome.
And I'm just going to run the local temporal server. So Temporal, a company, they have a commercial offering. That's how, if you were running this in prod, you would probably use Temporal's durable execution orchestrator, but there's an open source version for running it locally, which I'm going to use today. Sorry, Hugo, did you have a question?
No. I'm good.
So I'll just run that and it'll just say it's running on this port, which you see that we've connected to here. And with that running, I can now come over and I can run my durable execution example. And so I'm going to run the temporal example here. And you'll see it prints out a bit of stuff. In particular, it prints out the workflow ID. And it should now start chunking away, asking those questions as we would have seen before. What's powerful, though, is, as you saw, we got a broken error just on cue. This exception is just recovered from that. Basically, any error within an activity, Temporal is able to retry. You'll see it carries on working. And if I now go and kill it at question 5, you will see I can now effectively run the server again. In this case, all I'm going to do is, this is where I said I'm going to run the worker again, and I'm just going to wait on the answer to a particular job ID. You wouldn't normally need to do this, but if I just ran it normally, I would start running 2 different workflows at the same time, because each time I run the worker, it starts a new workflow. That will be confusing. So here, just to make things easier to understand, I'm going to run it again and specifically wait on this job ID. And so what you will see is once we get going, you'll see we go straight to question 6 in terms of what's printed out, and it continues. And if you want to understand how that works, you can come back over and see it in Logfire. So you'll see here within our trace, when we ran it for the second time, this trace here, you will see that the responses to the first 5 tool calls happened in a matter of a couple of milliseconds. And that is where Temporal is basically taking the cached answer and injecting it into the workflow from the activity so that you don't rerun those first steps. And then when we start running the following steps that need to still be run, it'll go back to running the activity. So running the LLM within each tool call. And it should at some point, see we're getting a few broken errors, but it is interesting how sometimes the LLM goes off on this particular challenge and will get itself confused and won't get to the answer, but you get the idea.
Fantastic. It's great to see Logfire integrated so easily as well. And
yeah, it's one of the really nice things about Logfire ultimately being an open telemetry, just receiving open telemetry data that we have done. We've done a bit of work to make this all add up, but fundamentally it's all connecting together because of open telemetry. It's the great thing about following open standards. And you can still we can see all of the details on token counts, on the tools registered with each individual agent, et cetera.
Super cool. And I know we've chatted about Evals a bunch in the past, and I know you've got your eval stuff happening there. I'm wondering whether you've found this type of evals can take a while and they can stuff up. How do you think about using durable execution for evals? Is that something you've worked on?
I think it's exactly the kind of case where you want it, because the last thing you want to have to do is to go and rerun the whole thing from scratch. I actually have some evals on this particular case. I'm just going to see if I think it's gone off. It's got confused.
It happens
you hold it in your hand,
the best of us.
It's got itself really confused. Is it flexible or rigid? Okay, I'm gonna kill that. I can actually, one thing I wanted to show, I don't know if there's any in this project here, but yeah, this is some evals I ran the other day on this exact case.
Oh, cool. Could you zoom in just a tad?
Yeah, I will. It's gonna be hard to read, is the truth, because it's a pretty complex screen, so you will have to tolerate it being ugly.
Yep.
But this is our view of the list of experiments, and then if I go and open a particular pair of experiments, we get a view of the relative performance. So here we're comparing GPT 4.1 to Gemini 2.5 Flash for the Q&A case. And you can see in terms of the assertions so this is interesting. You see it's saying that Gemini Flash did better than GPT 4.1. I think actually here that's a slightly incorrect result. There's a problem with the evals, input tokens and stuff like that, but more interesting. And I say we are a bit too zoomed in here for me to really to be particularly viewable. But what you will see is we can go through basically here we have the case names and the inputs. In this case, they're the same. So this is effectively the object that we're looking for. And then we have the one assertion on each side, which is whether or not it succeeded. And you will see that you'll see it succeeded 100% of the time with Google Vertex and some minority of the time with GPT 4.1. Now, as I said, in this particular occasion, this is incorrect, because what happened was that Google Vertex basically got bored and eventually replied and said, I can't find the answer. And when I wrote these evals, I haven't actually confirmed that it had found the right answer. So this is not a particularly accurate eval, but if you remove Gemini 2.5, which has this particular bug, and you look at two other models, 4.1 and Mini, you'll see in this particular case they did exactly the same number of failures. And then you can what's nice is that you can dig into the exact inputs and outputs that happened in each individual case. We don't have any custom metrics here apart from duration, but if we had them, you could see them. And because all of this is OTel data, if you want to go in and look at exactly what happened in the case of Gemini 4.1 Mini, in the case of House, you can go and look at the actual trace that generated it and go and dig in and see exactly what happened. I've kind of whizzed through the evals there without explaining everything, but hopefully that gives you some idea of how you can...
Yeah, super cool. And everyone, go and use your very generous credits to instrument with Logfire and check out the evals as well. We've got a question, is if there's a repo for everything you've just been showing. And I think I've just linked to Pydantic stack demo. Is it in that part of the repository?
Yes, I think it is.
There's a folder directory called durable exec. So
yeah. So it's here, and I can do that thing that some of you may or may not be able to see and take a picture of, which is the Remo, but basically, which is the link, but basically go to github.com/Pydantic and then look for stack demo and you'll find it, and you'll see all of the durable examples in this durable X directory.
Awesome. So I'd love to just chat a bit. I don't think because the deep research demo is there as well. People can go to that themselves. I wonder if just chatting through it would be ususe. And
yeah, absolutely.
It'd be great to know.
Yeah. So this is an example of, in fact, of what I was saying earlier, that like often the best examples, the best agents are made up of multiple sub-agents. So in this case, we define this deep research plan as a Pydantic model. This is a relatively unsophisticated example. I think if you were building a deep research agent, you would want something slightly more sophisticated in this case. But the plan comes with a kind of executive summary, what you might show to a user. This is what we're about to run. The web search steps, so up to 5 web search steps, which on this occasion just contain a search term. You'll see we're using attribute doc strings, so these descriptions here will become the descriptions for the parameters of the tool that is ultimately registered with the LLM. And then we have analysis instructions, which is kind of the rubric that the AI will ultimately use to evaluate the deep research. So then this is where we have multiple different agents. So we have the plan agent, and what it will return structured output, which is of type deep research plan. So this is how we effectively build our plan based on the term. Then we have the search agent, which uses relatively light agent, Gemini 2.5 Flash, with the built-in search registered here. So we'll use the search that comes from Google rather than registering a separate tool. And then lastly, we have an analysis agent where we're using a different model called Sonnet 4.5, and that will be fed the answer. And so that last analysis agent has access to search again if it really wants to call the search agent if there's something else it needs to go and look up. And I'm looking at the DBOS example, and I actually think I want the temporal example. There's quite a lot going on here, but ultimately what we're doing on here is we are running the plan agent, getting back our plan. Then we are running in parallel all of our web searches using the LLM. We'll collect those results, and we will use format as XML, which is our tool for basically smashing any old Python object into a kind of XML-ish format, which LLMs can understand. We'll pass that to our analysis agent, and it can then go and run. Do you want me to try and run it? And
let's do it. We've gone this far.
So the question I've asked it is, what's the best Python agent framework to use if you can care about durable execution and type safety? This was reliably returning PydanticAI. The other day, it committed sort of insulted me deeply and suggested LangGraph, which I'm deeply offended by. But we'll run it and we'll keep our fingers crossed.
Maybe LangChain's working on their agent
GEO rather better than I am.
Exactly.
You're probably right. Deep research, temporal, and I think the server is running over here. Yeah, server's running there. And if I run this, and I have not got excuse me, a Tavaliki there that I will put in. I better go and reset that after this.
Please.
And that will then go and run. Just one thing while we were. Oh yeah, that's the traces from Logfire as that's running. If I come over to live here, you should be able to see the deep research agent running. What exactly is going on? I'll just mention when we're talking about keys, you'll see that the previous examples I ran here, the model we were using always was prefixed with gateway. This is how we use PydanticAI gateway very simply. So we just have to set one gateway key where we can control limits, and then we can use any model with the one budget. So I would encourage you to go and sign up for PydanticAI gateway, and that will have to put a card in if you want to use our inference, or if you don't want to, you can put your own keys in, but again, use one key to access all of the major models. But while that is running, I will cross my toes that it's going to give the right answer, but we'll see what it says.
Yeah, and while that's running, I'm wondering if you could just speak to, and we've spoken about this implicitly throughout, but how this type of durable execution just relates to, builders' concerns such as memory and context engineering and all these things that we're trying to figure out at the moment.
I think that it's relatively orthogonal. I think that one of the problems you run into, we've got the answer. Oh, and for once it gave the right answer. It recommended PydanticAI, so that's good to know that it's right.
Amazing.
If you went through, so it recommended LangGraph second and Temporal on its own third. I have no idea whether Microsoft Agent Framework does a good job. I would guess not.
So I've just discovered these new sounds we can have here. I feel like a 70s DJ.
Thank you very much indeed. And you can see the full plan that it obviously gave a long report here where it's gone through the different options.
Yep.
Maybe our work on GEO is beginning to work again because this last week. But you'll see it's done a pretty good job here of summarizing memory and context. I don't think that I think it is a kind of orthogonal concern. I think the power is that you get to worry about building your agent, and the durability is for the most part. You write this kind of bunch of ceremony to set up your agent your durable execution framework of choice, and then you can get on with building your agent and not have to worry about that kind of infra side of things.
Yeah, that's a really good.
If you're using memory, sorry to interrupt. If you're using memory via tools, you'll want to have your tools set up as. I'm going to sharing my screen quickly. I'll just show you the full run here. Where did we get to? We had the last agent was here we are, analysis agent, and you can see here in Logfire the full report that we got out, as well as a summary of it here. I'll stop sharing my screen. So I think there are things like, if you're implementing memory via tools and you're going to go and store your memories in a database, you're going to need things like tools to be activities. Not doing so would mean that approach would not work. Any other regards, Hugo? Was there anything particular you were thinking of that I've missed where they overlap?
Well, yeah, I was just thinking if one of the concerns is we lose all state, essentially, when we think about memory or context engineering, we're offloading and isolating and writing stuff to different places for context. So, of course, Temporal solves all of this, but we may be able to recreate current state if we're using these kind of more advanced ways of thinking about context.
Yeah, it definitely makes it a heck of a lot easier to go and have multiple different agents that have their own individual tasks, where you can choose what model they want to use, where you can control what they have in context much more easily than if your durable execution concerns require you to have a single agentic loop or a single graph, in the sense of if you're still thinking that the right way to build agents is with graphs, that kind of thing.
Makes sense. I am wondering, do you have a few more minutes? I know we were going to stop at around 1:45.
Yeah, I can definitely do another 5 minutes.
Sounds great. I'm wondering, can you just speak a bit more to how it helps developers think less about infrastructure?
Yeah, I mean, I think if you were to go and set this up, let's ignore the alternatives out there, and we're going to go and set each of these things up as an individual task. Now I'm going to need to, you take the 20 questions example, which is very simple. We just call this tool in a loop. We can no longer do that if we want to do snapshotting at each one. We need to implement our agentic loop directly, and we need to you would run each individual tool call as a single task, which would then put a new job into the task queue, which would then be taken out the task queue and run. And that would then mean that we would have basically be able to store our state, a bit like the kind of climber climbing up the hill and inserting the thing into the rock at each step. So if they fall off, they don't fall too far. you would need to do the same thing, like basically stop yourself from going back to the beginning by storing the intermediate results so that we can resume. With durable execution, that is effectively taken care of with this very elegant activities versus workflow distinction.
Awesome. I'm also interested, the developer experience you showed seems really seamless. I'm just wondering if there are any costs we need to think about.
I don't know the exact cost of Temporal. I feel more and more like I'm a sales guy for Temporal. I haven't looked at them. I didn't show you DBoss today just because I didn't want to go into it, but DBoss is another option, and that is backed by Postgres. So you would just be using Postgres as your like store of state. I suspect that any of them, if you set them up right, the tokens you can save by setting up your context and your agent ontology correctly will save you many times what the durable execution stuff costs.
Super cool. Maybe to wrap up, I'd love to know, I mean, you've been building so much exciting stuff for builders and developers. I'm wondering what's exciting for you, and what are you thinking about next?
So we are working on managed variables, which is our take on prompt management. But the point is that actually to like control an agent, you want more than just that one string. So managed variables are basically a way of, it's a bit like context vars, but you can be managed externally in Logfire. So you can have your system prompt, but you can also have temperature and which tools are registered all set up as part of your managed variables that you can then go and tinker with, change in development, run your evals against them and see how that changes performance. I think this like prompt playground way of doing evals doesn't work that well, because ultimately if your agent's complex enough that it needs tools and it needs like specific responses from those tools, the only way to set up a really like version of your agent is in your own environment, staging, production, whatever. And so I think managed variables are going to be a really important step of that. And then twinned with them, we have prompt optimization or agent optimization coming. We'll be using the Jetha library. It's the kind of new exciting stuff, doing the DSPY kind of thing, but doing it in a hopefully type safe and more engineering rigorous way than DSPY. Those makes things coming in Logfire and PydanticAI.
Super cool. And to your point, I mean, prompt playgrounds can be super fun, but I don't know anyone who uses them seriously because they are so decoupled from what builders build.
I agree with you. I think there are those who have, look, I've heard from some customers that they're useful in some places. Maybe. I think it wouldn't be too hard for us to add a very simple like prompt space into PydanticAI Gateway. How useful that really is, good question. We may have to build it, but it's not that much work to do now that we have the gateway. So now that we can basically, use whatever model you like. Yeah.
So a bunch of people in the chat are super impressed, and particularly the restarting from where it stopped and crashed. We can punt this question as well, but Wilma has said she's been a big fan of LangGraph, may not be anymore after today, with a laughter emoji. I think you've spoken to this with respect to durable execution, but Wilma has asked, are there any other obvious advantages of using Pydantic and Temporal and Logfire over LangChain, LangGraph, LangSmith ecosystem when deploying agentic systems to production?
One thing I think it's worth just mentioning, I'll share here quickly. We do, in fact, have, although I don't always think graphs are the right answer to all questions, we've had Pydantic Graph for some time, and we have a new, what we call beta API, which is much more like functional API for graphs, where you get something much more similar to LangGraph, but compatible with Temporal. So you can basically run your graph as a workflow, and it can call agents within nodes, which will then automatically become activities. The main difference is that this is all type safe. David and Dower, who've worked on this, have worked incredibly hard to build a system where basically, if you see, like, we'll have the input type for this graph. Where's a good example? Basically, the inputs and outputs of connecting nodes have to be type safe. And so you get much of the LangGraph stuff, but it's type safe, and that we can get parallel node execution, but those nodes are run by Temporal or something. And so you're not having to, we can maintain type safety whilst having parallel node execution. That's a slightly different question, but I thought a relevant point to bring up.
Absolutely.
Sorry.
Yeah.
What was the other thing you were asking?
Any other advantages of using the Pydantic stack over LangChain and the Langstar ecosystem?
I think the number one thing is type safety that I've mentioned a number of times and will continue to bang on about. Secondly, I think the durable execution stuff that we've talked about. I think there are lots of other like nice to have things that individually don't make much difference, but sum up to be pretty valuable. We have 100% code coverage all of the examples in our documentation are run as part of CI, as part of unit tests. So you won't have examples that are out of date. I think that we're moving pretty quickly, adding some really exciting stuff. I think we think we come from an open source background. We maintain infrastructural bits of the Python ecosystem, both within the company and as a team. And I think bluntly, the caliber of open source that we're doing is better than other people. That's obviously more subjective. I think the first 2 points are where you can be objective. I think we come from structured outputs are obviously our bread and butter with Pydantic. We have support for multiple different ways of doing structured outputs in PydanticAI, which I think sets us apart from some of the others.
Great. And the other answer is, of course, go and experiment with yourself and see how you can instrument everything with Logfire and all your evals. And
I mean, what we find is once people find PydanticAI and get using it, they don't go back. But of course, there'll be some people who find other things useful, and that's fine. That's why, luckily, there's lots of choice.
Yeah, exactly. Well, as always, Samuel, I appreciate you coming in and speaking to the course, and appreciate all the credits. You've been so generous, you and the team, in provisioning for all the students. So thanks.
No problem. Thank you so much. It's a pleasure. Nice to see you. Bye-bye.
Thanks for tuning in, everybody. And thanks for sticking around until the end of the episode. I would honestly love to hear from you about what resonates with you in the show, what doesn't, and anybody you'd like to hear me speak with, along with topics you'd like to hear more about. The best way to let me know is currently on LinkedIn, and I'll put my profile in the show notes. Thanks once again, and see you in the next episode.